Hi everyone, in this video we are going to check how to implement in Python the Box-Müller method we saw at the beginning of this Monte Carlo tutorial. So let's start importing the usual libraries. We are going to need NumPy and matplotlib to visualize the samples. So let's start defining our Box-Müller function. To generate the Gaussian samples, remember, we will need in this case mu, sigma, and the number of samples. So internally, this function needs to generate the uniform numbers, remember, s and t, and then implement the same equations we saw in our previous video. I'm projecting the equations here. So let's do that. So note here that in order to generate a final amount of, let's say for example, 1,000 Gaussian samples, we will need to generate 500 samples S, 500 samples T, and then since we have two different equations to generate X and Y, by putting those samples together we will end up in the exact number of samples we need. So that's why here I'm gonna generate just half of the samples for S and half of the samples for T. Okay, so we generate T here. Let's make sure that we have a random seed. Okay, now we just need to implement the equation. So remember, the equation for X was the following. And Y was almost the same. So let's stack these samples in a matrix before returning them. So if we transpose this, we're going to get the samples as columns. Let's try our function. Sorry, made a mistake here. We need to add another parenthesis. Okay, so let's plot our samples. Let's try first with an histogram. So the first column is going to be our X samples. Let's use 50 bins. Okay, so let's add the other set of samples in the second column. Here we go. So actually, well, let's plot them separate for now. So we can see that here we have two sets of samples from a normal distribution, and we can plot them both together now by using a scatter plot. Let's use this color. Sorry, just need to cast this as an array again. Here we go. Okay, so this is kind of like a normal distribution where both variables are independent, right? Okay, I think we still can improve a little bit our code. The first thing we can do here is, for example, justifying one variable for this piece of code that is repeated. So let's call this R, for example. And we can call this theta. Something else we can do is to receive the seed as an optional argument and use the random number generator from NumPy, which is a bit better than the random that we're using here. It has better random algorithm generation, and it provides more state isolation, right? Because we will not depend on external or global seeds. So let's call this RNG. And here we can use RNG instead of np.random. Okay, so let's provide the seed here. So that's it. See, after we understand the equations, the implementation is quite simple.